One of the things that makes Peak's climbing mechanic feel so good is how the character's animations respond to the movement. Welcome to the third episode of Behind the Mechanic, where we reverse engineer popular game mechanics and recreate them from scratch in Unity. In the last video, we created a player controller that could move, rotate, and jump, and added the core climbing mechanics, detecting walls, climbing in any direction, rotating around wall corners, and mantling onto ledges. In this video, we'll bring our climbing system to life by setting up the character mesh, adding the climbing animations, and connecting everything to our player controller. So let's start where we left off. First, we'll be adding a character mesh to our player controller. I've used this Jamo character from the asset store. You can find the link in the description. Let's drag that here, add it as a child. We'll copy the capsule collider component from the capsule mesh and add it to the root game object. Now let's position the character mesh correctly. Looks good. Now we can delete the capsule mesh. Now let's create an animator controller which will contain all the animations and transitions. I'll name it Jamo Anim Controller. Let's open it and create a new blend tree. I'll name it Locomotion and open it. It will be a simple 1D blend tree. Let's add a motion field for the idle animation clip. This is the idle animation and this is the running animation that we'll be using. Let's add the idle, add another motion field and add the running animation. Now we'll change this blend parameter name to speed, which is a float value, and we'll be controlling this via script. Now as you can see, when we change the speed from 0 to 1, the animation blends from idle to running. That's the magic of the blend tree. Let's create a script to handle the animations. We'll call it Player Animation Controller. We'll have a reference to the animator, the player controller, the climbing controller, and the rigid body component. Now let's cache the speed parameter using animator.string to hash instead of passing strings like speed every frame. Unity converts them into integer hashes once when the game starts. This is slightly more efficient and also prevents bugs caused by typos. We'll have an update function and let's create a function update movement animations and call it in the update. Inside the function, we'll set the speed float to the player's move input, but first we need to make it accessible and then use its magnitude and have a damping time of 0.1f to make it smoother and pass time.delta time for the damping. Now let's go back to Unity and add the missing references. Let's add the animator component and add the reference to the controller, the avatar, and also remove the animator component from the mesh game object. Let's add the player animation controller script and add the reference to the animator, player controller, climbing controller, and the rigid body. Now let's play, and as you can see, the character plays idle animation at the start, and when we move, it's playing the running animation. Now as you can see, the character's head and some other parts are overlapping with the camera, which looks weird, so we'll fix that. Let's select all the parts that seem to overlap with the camera, mostly the head and the torso, and we'll set the layer to the character mask layer which I've already created. And in the main camera culling mask, we'll exclude the character mask layer so that these parts are not rendered by the camera. Also, we need to make sure that all the skin meshes have this box checked, which ensures that the meshes animate even when not in the camera view. Now let's play, and as you can see, the head and the torso are not visible, and we can only see the arms and the legs. Now let's go back to the animator controller and we'll add an empty state for the jump animation. And here's the jump animation I'll be using, which is from Mixamo. Mixamo is a free online platform by Adobe used to automatically rig 3D character models, apply pre-made motion capture animations, and download the animated assets for games, films, etc. If you don't know how to upload your character to Mixamo and download animations, I've linked a short video in the description. Now let's add the jump clip and we'll make it transition from any state since we want the jump animation to be played from any other animation state. And we'll create a trigger parameter and name it jump and add it in the conditions for the transition to jump state. Let's create another state falling and we'll have a transition from jump to falling. Let's create a bool for falling and add it in the conditions where falling should be true and disable has exit time. So the character will transition from jump to falling only when the falling bool is true. We'll also have a transition from locomotion state to the falling state, disable has exit time, and the condition falling to be true. Lastly, we'll have a transition from falling to locomotion state, has exit time false, and the condition being falling to be false. I forgot to add the falling animation, which is also from Mixamo. So this makes the animation transition from locomotion to falling when the falling bool is true and back to locomotion when the falling bool is false. Let's create another boolean parameter grounded, which will get the value from the ground check. Let's go back to the player animation controller and cache the parameters that we created in the animator. One for the grounded, one for the falling, and one for the jump. Now in the update movement animation, we'll set the animator's grounded bool to the player controller's isGrounded value. Let's also create a local bool falling, which will be true if the player is not grounded and the rigid body's linear velocity in the y-axis is negative and the player is not climbing. Now we'll set the animator's falling parameter to this falling bool. Now let's create a function to play the jump animation and we'll set the jump trigger here. And we'll be calling this from the player controller but not directly. We'll create an event action on jump here and invoke that here in the jump function. Now we'll go back to the player animation controller and in the on enable subscribe to that on jump with our play jump animation function and unsubscribe from that in the on disable. Now let's go back to Unity and test, and as you can see, when we jump, it plays the jump animation followed by the falling animation and finally transitions back to idle. You can also see the flow here in the animator, from jump to falling to locomotion. Now let's set the animations for climbing in the Animator controller. I'll create another blend tree and name it Climb Locomotion and then open it. This is the idle animation that we'll be using when the character is just hanging and not moving, and this is the climbing animation that we'll be using. But if you want to make it more realistic, you'll be needing animations for moving left, right or down while hanging and use a 2D blend tree for that. Let's add the motion fields for the hanging idle and the climb up animation and drag those clips here. Now we'll create another float parameter climb speed and we'll set the parameter of this blend tree to that. And now when we increase the climb speed from 0 to 1, the character blends from the idle to the climb up animation and back. I'll create another bool parameter climbing and then go back to the base layer and make a transition from the climb to the ground locomotion and back and set the condition here for climbing to be true and here the climbing to be false. So the player will transition from ground locomotion to climb when climbing is true and back to ground locomotion when climbing is false. We'll also have a transition from climbing to falling and the condition will be falling to true, which is basically when the player releases the left mouse button to exit climb. Also make sure to disable the has exit time from these transitions since we want them to transition based on the conditions and not on the duration of the animation clips. Now let's go to the player animation controller and cache the parameters for the climbing and climb speed. Let's create a function update climbing animation and here we set the climbing parameters value to the climbing controller's isClimbing bool. If the player is not climbing then we return, but if climbing is true, we set the climbing speed to the player controller's move input magnitude just like in the movement animation and pass damping of 0.1 and time.delta time, and we call this in the update. Now let's go back to Unity and play, and when we approach the wall and try to climb, the climbing animation plays, but there's a gap between the wall and the character. So let's decrease the climb offset to about 0.1 and also the climb speed to 1 since the current speed does not match with the animation speed. Let's also reduce the capsule collider's radius to 0.3 so that we can get closer to the wall. Now let's play, and now the character sticks to the wall, but in the game view you can see that the camera is so close to the hands that they get clipped. So we'll go to the main camera and decrease its near clipping plane to 0.01 and also move the camera pivot slightly back so that we can see more of the hands when we climb. Now let's play, and as you can see, we can properly see the hands playing the climb animation and the character is moving upwards nicely. So the next thing we need to work on is the mantle movement and animation. As you can see, when we reach the top, it's still playing the climbing animation and the character does not properly mantle up the ledge and instead falls down when we release the left mouse. So let's go to the climbing controller and declare properties for the ledge check height, ledge check forward distance and mantle speed. To detect if we can mantle up a ledge at the top of the wall, we'll do a raycast from a slightly forward and upward point, for which we use the ledge check forward distance and the ledge check height. Let's also add a bool for isMantling, a vector3 variable to store the mantle up target and a vector3 to store the mantle end target. So the mantle is basically divided into two phases where the player first moves a bit upwards to the mantle up target position so that it's no longer blocked by the wall and then moves forward to reach the mantle end target, which will be calculated by the raycast, and we'll also have a bool moving forward. Now in the tick function, we'll remove the check for the wall lost timer to exit climb as we'll add that in the handle lost wall function in here. We return if the isClimbing is false or isMantling is true and then add the check for the wall lost timer to exit climbing. Now we'll try to find a ledge here, so let's create a function tryFindLedge with return type bool and an out parameter vector3 mantle end. We'll first set the mantle end to vector3.0 and then create a vector3 to store the ray origin, which will be at the transform.position plus the detection offset with the ledge check forward distance multiplied by the player visual forward direction and the ledge check height multiplied by vector3.up. Now we'll raycast from the ray origin in downwards direction, passing the raycast hit with the distance of the ledge check height multiplied by 2 and the climbable mask as the layer mask. If the raycast does not hit the ledge, then we return false, but if it does, then we store the player's capsule collider. First we make it accessible, and then we calculate the distance from the character's pivot to feet, which is half of the collider's height minus any center offset in the y-axis, and the mantle end will be the hit.point where the raycast hit the ledge plus vector3.up multiplied by pivot to feet and return true. This will give us the end point on the ledge where the player should reach to complete the mantle up. Now in the handle lost wall, we call this function and pass an out parameter mantle end, and if it's true, then we start the mantle. So we create a start mantle function with a vector3 mantle end parameter, and inside we set isClimbing to false, isMantling to true, and the mantle end target to the mantle end parameter. And the mantle up target will basically be the current position of the character with the y value of the mantle end target. Let's also create a getMantleVelocity function which will return a vector 3, and here we create a vector 3 target which will be the mantle end target or the mantle up target depending on the bool moving forward. If moving forward is false and the distance between the current position of the player and the mantle up target is less than 0.05, then we have reached the mantle up target and we'll set moving forward to true, since we now want to move forwards. If the moving forward is true and the distance between the current player position and the mantle end target is less than 0.05, then we have reached the end position. So we'll return vector 3.0 as we no longer need to move, and at the end we'll return the direction from the target to the current player position by normalizing the difference and multiply that with the mantle speed to get the velocity. We'll create one last function finishMantle where we'll set moving forward to false, is mantling to false, enable gravity, and rotate the player towards the camera forward just like when we exit climbing. And this will be public since we'll be calling it from the player controller. Now let's go to the player controller, and in the fixed update we check if we are mantling and then set the velocity to the climbing controller's getMantleVelocity and also set jump press to false. Make sure to add the start mantle in the climbing controller if the try find ledge is true. Now let's go back to Unity, add the reference to the capsule collider in the player controller, and now we'll move up the climb offset so that as soon as the character's head reaches the top edge of the wall, it detects wall lost and starts mantle. Let's also set the ledge check forward distance same as the wall detection distance, which is 0.8. Now let's play and see. We're climbing, and as we reach the top, the character moves upwards and forwards to reach the final point. So now we'll add the animation for the mantle, and also as you can see we can no longer move since we're still in the mantle state, so we need to reset that as well. So let's go back to the play animation controller and cache the mantle parameter and create a function playMantleAnimation where we'll just set the mantle trigger. Now let's go to the climbing controller and create an event action on mantle, and we'll just invoke that in the start mantle function. Now in the player animation controller, we'll subscribe to that event with our playMantleAnimation function and also unsubscribe in the onDisable. One last thing, in the climbing controller track current wall, we're calculating the ray origin using the detection offset directly, which makes it wall space. So to convert that into local space, we'll use transform.transform direction and pass the detection offset and copy the same in the onDraw gizmos. Now let's go back to Unity, to the animator, and here's the mantle animation that we'll be using, also from Mixamo, but it was moving the entire character, so I had to import this into Blender and remove the upward and forward movement keyframes since we're controlling the movement through code. I've also linked a short video showing the steps to do that. So let's create a mantle state and add this animation clip. I'll just reorganize the states a bit, and let's create a transition from climb to mantle state and a trigger parameter mantle and disable the exit time here and set the condition of this transition to mantle. From mantle, we'll transition to locomotion and the has exit time will be true here with the exit time being 1, which means the transition will happen once the entire clip has played. Now there are some other transition conditions that I missed to add earlier, so we'll add those now. Like from climb to falling, grounded should be false. Also transition from falling to climb with the condition falling to be false and climbing to be true. From falling to locomotion, grounded should be true. From climb to locomotion, grounded should be true. There will also be a transition from jump to climbing with the condition of climbing to be true. I think all the conditions are correctly set now. Just one last thing, which is in the mantle animation at the end, I've added an animation event where I'm calling that finishMantle function of the climbing controller where we are setting is mantling to false and enabling gravity and all. So let's go back and play. And as you can see, when we reach the top, we nicely mantle over the ledge and climb up, and the character can move now as well. So now we have a complete climbing system with a character mesh and animations for movement, climbing up walls, mantling at the top, and jumping from one wall to another. And so far, it looks pretty good. To make the climbing animations even more realistic, we can add IK to the hands and the feet so they actually stick to the walls, and add animations for moving left, right, and down while climbing. But we'll leave that for the next part of this episode. That's it for today's episode of Behind the Mechanic. If there's another game mechanic you'd like me to reverse engineer, leave it in the comments and I'll see you in the next one.